Good morning for those of you that are have already joined. We're just going to wait a few more minutes as people enter from the lobby into the webinar. All right, it is 9:02, so I think we'll go ahead and start, and we'll let people continue to join if they are doing so. Good morning, and thank you for attending our webinar this morning. The topic for Earth Day 2021 is on restoring the Earth, and CNL is proud of the work that we are doing, restoring our sites and ensuring that we are protective of the environment throughout all of our operations and decommissioning activities. Please check out CNL's website, cnl.ca, for more information on CNL's environmental work. In line with Earth Day, the topic for today's session is on protecting the environment before, during, and after the WR1 decommissioning, providing participants with a snapshot of what has, is, and will be done to ensure the proposed in-situ disposal is protective of people and the environment. My name is Alana Wilcox, and I'll be facilitating today's session. Along with me is Brian Wilcox, the Director of WR1 Reactor Decommissioning Project, Jeff Miller, our Technical Lead and Manager of the Regulatory Approvals for the WR1 project, and Chuck Kitson, the Environmental Specialist for the WR1 project. This session is planned to last approximately 1 hour, including question and answer period. Questions may be typed into the Q&A window located at the bottom of the Zoom webinar screen at any time during the webinar and will be answered at the end of the session. Alternately, you may email questions to wlcommunications@cnl.ca for follow-up after today's session. And I will put that email address into the chat box later on. Thank you, and we hope you enjoy. Jeff, I'll pass it over to you to kick it off.
Thanks, Alana. Good morning, everyone. My name is Jeff Miller, and I am the Acting Manager of Regulatory Approvals for the WR1 Decommissioning Project and the Technical Lead for in-situ disposal of WR1. Now, today is the latest in our series of webinars, and we'll focus on how we monitor the impacts of our operations on the environment, both now and moving forward into the future. So to start things off, I'm going to give you just a little bit of general background on the site and the WR1 decommissioning project before turning things over to Chuck Kitson, one of our environmental specialists at Wet Shell, to speak to how we monitor the environment at Wet Shell and how we will continue to monitor after the in-situ disposal of WR1, followed by a Q&A period wrap up at the end. So for those of you who aren't familiar with our site, the Wet Shell Laboratories research site is located in southeastern Manitoba, very close to the longitudinal center of Canada, on the border of the prairie grasslands and the boreal forests. It's approximately 100 kilometers northeast of Winnipeg and is on the shores of the Winnipeg River. Now, this is an aerial view of the Wet Shell site, and it's more or less as it exists today. And it does look a lot like a college campus. Now, forgive me, I'm having a little bit of trouble here with keeping my slides where I want them. Chuck, if you don't mind, would you flip back to the aerial view? All right. So like I said, it does look a lot like a college campus, various buildings that serve various purposes, housing staff or various research projects. But it really centered around the WR1 reactor building, which if we can manage to get that slide to say, you'll see it's outlined in red there. This wouldn't be a webinar in this day and age with a little bit of technical difficulties. But you can see that building actually represents a very small portion of the overall campus itself. All right, we'll keep it on this slide here with the reactor facility, Chuck. So while WR1 was the focal point of most of the research that was done at White Shell for many, many years, and now represents one of the most challenging decommissioning projects we have here at the White Shell Closure Project. It was a 60 megawatt reactor that's purpose was to test the use of an organic coolant for a nuclear reactor, and did play a very important role actually in the development of the modern CANDU reactor design. You can see here in two photos. The one on the left is the main reactor hall, more or less as it exists today. You can see two large fueling flasks that would be used to move fuel in and out of the reactor, as well as the rotating deck plate underneath them, which would actually be how you would access the reactor core itself. On the right is a photo of the calandria, or the reactor core, back in 1963, when, just as it was first being installed. Give you a sense of the actual size and shape of the reactor core. Next slide, Chuck, please. So WR1 was constructed between 1963 and 1965, so over a period of about 18 months, from a hole in the ground to a commissioned operating reactor. The area was excavated down to bedrock, approximately 65 feet, and the whole building itself is approximately 5 stories deep. It operated for 20 years, from 1965 to 1985, and then shut down permanently at the end of its research mission. It was then defueled, drained, and put into safe storage with surveillance, and has been in the storage with surveillance state ever since. So you can see here in this image, again, that shape of the reactor core. You can see the reactor core it's level 300 technically, so it's about halfway from the surface to the ground floor, just right of the center in the photo there. And this reactor core is actually where the overwhelming majority of all the remaining radioactivity in the facility is. The activity is trapped within the metals themselves, and as a result, which is a result of the neutron activation of those core components. Now, what we're proposing to do is to decommission WR1 in situ by creating a permanent passive disposal site out of the reactor facility itself. The above grade structures are demolished and removed, and the below grade structure is backfilled with grout and capped with an engineered cap and cover. What you end up with is a multi-barrier waste disposal system, as you can see here on screen. The first barrier really is the waste form itself, so the reactor core components. They're made of stainless steel and zirconium alloys, which have very, very low corrosion rates. And so before anything could ever be released from the facility, those components would have to corrode and break down and dissolve into groundwater, which is a process that would take tens of thousands of years. The second barrier is then the concrete bioshield or reactor vault walls, which are made of heavy, thick, reinforced concrete and steel, which are incredibly tough and suitable barrier as it is. But surrounding them is the interior walls of the rest of the structure. So again, reinforced concrete walls. The fourth is the grout that's going to fill all of the void spaces, or as much of the void spaces as is practical within the facility. So the reactor core itself, the bioshield, the internal walls and floors, and then the grout itself. And then surrounding all of that is the existing exterior walls. Now, most of these are reinforced sulfate resistant concrete, and in some places as thick as 4 feet. We've done an assessment of the condition of these walls already, and they are still in proper working order, very strong, very stable, and no signs of significant deterioration. Now, the sixth barrier to all of this is the engineered cap and cover, which would be placed on top of the facility. And this is really what's going to resist intrusion, either by plants or animals or inadvertently from humans. And it's also going to reduce the amount of water that can pool on the surface or infiltrate down into the facility. The seventh barrier is the geosphere itself surrounding it. So in Manitoba here, we have very thick clay overburdens and very, very slow moving groundwater on our site. So between the slow moving downward movement of the groundwater and the clays that impede the movement of contaminants, we have very good geological conditions for hosting a waste disposal facility. And then of course, the final barrier is our institutional control. So fencing, signage, control of ownership and development at the site. All of these things provide an additional barrier to prevent potential exposure to or releasing contaminants from the waste disposal facility. Next slide, please, Chuck. Thank you. So in order to move forward with this plan, CNL has to get approval to proceed from the CNSC through a federal environmental assessment process. Currently, we are at the stage where we are about to resubmit our revised draft environmental impact statement. And if that is accepted for review, the timeline for the final EIS or environmental impact statement submission, public hearings, and eventually a final decision on the project will come later in 2022 or even early 2023. Now, before we move into the next part, to say if you have any questions on the project in general, please feel free to drop them into the QA and we'll circle back to them at the end. But with that, I will turn it over now to Chuck Kitson to take you through our environmental monitoring plans for the project and the site overall.
Thank you very much, Jeff. As you can see, we're having a little trouble with our slides. We'll try and minimize that. I'm Charles Kitson, an environmental specialist on the site, although we have a large group of us that support the Whiteshell site and the WR1 project. At Whiteshell, we have an integrated environmental monitoring program, and this really encompasses three major components: our effluent verification monitoring, environmental monitoring, and groundwater monitoring. And I'll speak to each one of these in order. So first, we'll be looking at the effluent verification monitoring. The effluent, our monitoring program and plan was issued and follows the guidance provided in the Canadian Standards Association CSA N288.5 and is currently being executed to comply with the Whiteshell conditions in the Whiteshell decommissioning license and license condition handbook. It also follows our environmental protection quality assurance plans and procedures, and also CNL, Canadian Nuclear Laboratories policies and other applicable regulations and standards such as federal wastewater, and aligns with, as we indicated before, Canadian Standards Association CSA N288.5. So for our effluent verification, we look at liquid and air emissions. These are, when we say effluent, we're looking at things that leave the site. First, I'll be speaking to the liquid effluent that leaves the site. The two main monitoring points for the Whiteshell site are the lagoon and our domestic, which houses our domestic water waste, waste from staff bathrooms, flushing toilets, domestic drains, your standard, more or less, waste that you would have from a industrial operation for domestic waste. We monitor this continuously during our releases from the lagoon are monitored continuously during our 2 discharge periods in the course of a year. We also have an outfall, which has we monitor continuously throughout the year, and this allows water to flow to the Winnipeg River. This is water from our storm drains, our roads, and water from our radiological facilities via controlled pump outs. So nothing is released from our radiological facilities until we've sampled it, tested it, and we have approval that it meets our rules and regulations before we release. We have this figure also shows our lagoon up on the left side, upper left, our outfall where it leaves the main site on the mid left, and it proceeds to the Winnipeg River. Building 100 and building 200, which have monitored releases that go to our outfall. And these are the locations where we pre-test these releases before they are allowed to be released from the site. Building 200 was historically our active liquid waste treatment center. This building is being decommissioned, so we no longer have releases from this location. So what do we look for? Well, for liquid effluent from a radiological point of view, we look at what we refer to as gross alpha and beta and gamma spec. So the gross alpha and beta give us a good feel for how, what level any radioactive activity could be. We have very strict guidelines for what we can release, and the gamma spec breaks that down into individual radionuclides. We also specifically look for strontium, tritium, cesium, uranium, and plutonium, because these are historical wastes that are known and products that are known to be on site. We don't only look at rad, we also look at non-rad, and these are pretty standard things that any industrial location would be looking at, including pH, conductivity, suspended solids, oil and grease, metals, biological oxygen demand. I won't go through everything, but these are things that we monitor 24 hours a day, and for release to our outfall. So we sample them every day. We do analysis every day. So what type of results do we get? Well, from a RAD point of view, we are approved to release to a certain limit, and this is approved by the Canadian the CSA, well, Canadian CNSC, Canadian Nuclear Standards Association Commission. Sorry. Anyway, and we are given what's referred to as a derived release limit, and that's what we're allowed to release to. These two plots are showing the same information. The plot on the left is showing what we've released over the last 6 years, and is really a blow up of what's on the right. If you notice, it on the left-hand scale is the percent of derived release. The upper level on the plot on the left is 1% of our derived release limit. So over the last 6 years, we've never released above 1% of our limit. So we're well below our legislated limit. If you want to think about this in a more realistic way, if you look at the plot on the right, I'm showing here our derived release limit, which is 100% of our derived release limit. So what we're allowed to release to. And if you plot those bars on the left on this scale, you can see they barely rise above zero. So we are well below the limits, and have been, as you can see, for the last 6 years, we are well below our limits. So we also, as I mentioned, we also look at liquid and air emissions. And now I'm going to talk about the air emissions. So we have this slide shows locations of our current air effluent monitoring in facilities, including Building 100 and Building 300. Again, like our other slide looking at liquid emissions, we used to monitor at Building 200, but it is being decommissioned currently, and it no longer has air emissions due to operations. In the method in which we monitor Building 300 and 100 is we we're continuously sampling the air that is exhausted through the filters. We then take these filters and we examine them for, send them to the lab, and we look at our beta and gamma results. We also and then analyze the results after. So we look at similar parameters for our radiological parameters. We look at gross alpha and gross beta, giving us a feel for the radiation levels. And also we do a gamma spec to give us a detailed information on what potential radionuclides specifically are being released. Similar to our liquid emissions, I'm showing you the plot of what our derived release limits, which again is what we're allowed, or what we're regulated to not release above. And this is a very similar plot showing the figure on the left up to a very low level of our percent of derived release. And the figure on the right shows the full release limit of derived release limit at 100% of the red dashed line on the top. What's interesting compared to our liquid and our air emissions, you can see that our liquid emissions were very low. These are even lower. So we are releasing at 0.0003 over the last 6 years. That's our maximum percent of our derived release limit. So again, these numbers really don't climb off the zero axis. So our releases are very well controlled and well below the standards and the regulative levels. Now we also monitor for non-radiological parameters, specifically during our building decommissioning activities. So we set up monitors around the site to capture dust particulate. During demolitions, we do this 24 hours a day, 7 days a week during a demolition. And we do this to show that we are not releasing dust to the environment. We also calculate air emission estimates, such as greenhouse gases, and we base this on the consumption of fuels on site, gas estimates that are coming off of our landfill, and if we are doing any burning, we estimate the greenhouse gases that could be released from a burn pile. We also participate in the National Pollutant Release Inventory estimates, and this is based on, again, consumption of fossil fuels and travel on unpaved roads. And we've recently entered into the Global Reporting Initiative, which is new for us, and this is sustainability reporting. We're reporting energy consumption, emissions, water use, and consumption. And this registry, for example, has a participation of about 10,000 reports, and from over 100 countries. And it's a movement to advance the sustainability reporting to enable businesses to use this information to engage in dialogue and make decisions that support sustainability. So we've looked at the physical releases. Now, how do we impact the environment and how do we monitor? And again, our environmental monitoring plan has been issued following the guidance provided in the CSA standard N288.4 and 288.4, and is currently being executed to comply with our site license and our license condition handbook. Well, first off, where do we monitor for environmental parameters, or do our environmental monitoring? Well, we do it on site. We do it upstream from the site and downstream from the site. And what are we looking at collecting? Well, we look at we collect water samples, sediment samples from the river, and fish. We look at our drainage ditches. We collect water from our drainage ditches, and we take soil samples. We take natural vegetation samples. We get garden crops from the area, and we also investigate any game animals that are generally supplied through roadkill, unfortunately, in and around the roads surrounding the Whiteshell site. We also measure the ambient radiation dose with monitors around the site, and this is for and off the site. So we have monitors directly on the site to see if there's any difference between that and other monitors off-site. Where do we do this? Again, I said upstream and downstream. So we go as far upstream as the town of Pinawa, which is approximately 10 kilometers upstream. We go downstream as far as the Great Falls Generating Station, which is 28 kilometers downstream. And you can see all of the locations here listed are several of our sampling sites. Now we're also always looking at the biodiversity monitoring on site. In the past, we've used acoustic monitoring for bats and songbirds. Every year we do an annual nest identification. We go around the site and look for who's here, like what birds are nesting. We do a regular species at risk habitat check to see if specific species at risk, is their habitat disturbed? Are they still inhabiting that habitat? This season, we have plans for the WR1 project in support of the WR1. We're doing a bat exit survey and an internal summer roost check. And so we actually set up monitors and sound measuring devices to identify the bats, find their flight paths, see if they're entering or leaving the WR1, or are they in the surrounding environment in the trees surrounding the site. We're also going to be doing a turtle survey and search along our roads to identify what types of turtles, how many turtles, and where they are on our site. And another big project we're going to have is we're going to be doing a tree survey and a songbird survey. And this will be supporting the potential development of a borrow pit area to provide clean, low permeability clay for the decommissioning, backfilling of buildings and decommissioning of this site. Now we look at the environment, we look at what we're releasing from the environment, and we look at what's in the air. We also look at what's below. We look at what's in the groundwater, and can we, and this is to make sure that we're not contaminating groundwater. Groundwater is not providing a pathway for release of potential hazardous material to the environment outside of our site or into the Winnipeg River. Our groundwater monitoring plan has been issued following the guidance provided in CSA N28.7 and is currently being executed to comply with conditions in the Whiteshell Decommissioning License and License Condition Handbook. We have again, this is a bit repetitive, but we have an environmental quality assurance plan for our groundwater monitoring plans, and this is compliant with CNSL policies and other applicable regulations and standards, which complies with CSA N28.7. So what do we look for, or where do we look on site, and what are we looking for? Well, we have our waste management area, which houses historical waste, safely stores historical waste. We have a landfill for our non-rad waste, and a lagoon, which we've discussed before, which has our domestic water and waste. And then we have our main campus, and we monitor, which includes the WR1, which is at the center of our main campus. And we monitor through wells and well nests, groundwater in all these areas. What are we looking for? Well, on a RAD site, we're looking from a RAD point of view, we're looking for very much the same as we look for in the other components. We're looking at a gross alpha and beta. We're looking for tritium, which is in the groundwater, potentially in the groundwater, uranium. We also look for non-radioactive water measurements or non-radiological water contaminants. We determine the water levels measurements for each of our wells, and this then feeds into our hydrogeologic study for understanding how the groundwater moves. And we sample these wells semi-annually. Now, how many wells do we sample, and where are they specifically? Now, we have a lot of wells in total. Currently, we are actively sampling 140 wells semi-annually. Each one of these wells, as you can see, this is a figure representing the Whiteshell site. The WMA has a lot of wells up gradient and down gradient, and within the WMA area, we have wells around our landfill, which is up on the right-hand side. Just above the main Whiteshell site, which is Whiteshell Laboratories on the lower left, we have the lagoon, and we have wells surrounding the lagoon to make sure that we're not getting penetration of materials in the lagoon into the soils and groundwater surrounding the lagoon. And then we also have wells on the Whiteshell Laboratories main site. And as I indicated, we have approximately 140 wells, and each one of those wells is sampled twice a year. And depending on which well it is and the history of the wells, we do anywhere from 10 to 20 parameters per well to over 100. So we gather a very substantial amount of data in terms of what's in the groundwater, is it moving, and also a lot of information on how the groundwater itself moves. Now, if we want to look at the main campus, you can specifically with regard to the WR1 and where our wells are located. In this plan view, the WR1 is represented as the purple highlighted figure in the middle. And as you can see, it is specific. It is just about dead center of our main campus. The wells are represented by the red squares surrounding, and this is a very key thing, surrounding the main campus and the WR1. So from a plan view perspective, we have the WR1 surrounded. The groundwater movement, although very slow on campus in the horizontal direction, is from the right-hand side of this figure to the left, which is east to west. And although it's very slow, it does drift slightly towards the river. So the wells, which are indicated as 1, 2, and 3, are up gradient from the WR1 and give us background levels of the water entering the main site. Wells 4, 5, 6, 7, and 8 give us the condition of the water down gradient of the WR1 and the main site. So we can do a comparison, up gradient and down gradient. And this gives us not only indication of what's in the groundwater, but also, again, we monitor the actual elevations of these wells. And each one of these locations, these nests, has from 4 to 7 wells at different elevations, giving us multiple layers of the soil stratigraphy down to bedrock. Several of the wells go down to bedrock, as I'll show in the next figure. So we have, from our point of view, we have the WR1 surrounded in the plan view. And if in the next figure, which I'll go to now, we also have the WR1 surrounded in the vertical. And I'm bringing out my laser pointer here. This represents the WR1 building going down to depth, which is just sitting on the bedrock. This over here is the borehole log showing the which was taken at the drilling of this well, and this is our deepest well on nest 2, and there's 5 wells there, and this goes 10 meters into the bedrock. So this is on the up gradient side. If we look on the down gradient side, we have nest 4 and nest 8. We also have nest 5, and this line, which was the horizontal, was that blue line on the previous slide, which I'll bounce back to. Good. Well, it's not going to let me, but the okay, anyway, this, you can see that nest 4 and 8 go to great depth below the WR1. There's also wells in the overburden, and this shows it vertically, and we have the WR1 surrounded and horizontally. So try and go to the next slide. Jeff, could you move me to the next slide?
I can try here.
Yeah, just my screen's not letting me. Thank you. Okay, now the CNL Environmental Protection Program is built on the principles of ISO 14001. We've been certified since 2010, and we go through a annual accredited third-party audit. So this is allowed us to build a very comprehensive framework and develop our environmental program. Next slide, please. Now, how do we report? And we do regular reporting. The annual compliance reports are prepared each year, summarizing the activities conducted under our effluent verification monitoring, which we talked about, and our environmental protection and groundwater programs. Every year, these are reviewed, and refinements and improvements to the programs occur at least on an annual basis, if not semi-annually. Each year, we produce an environmental assessment follow-up program, and this, in addition to our other shows, is specifically tailored to showing how we're following up on commitments that were made when the Whiteshell site was designated as a decommissioning project, and to show that we're being safely and efficiently complying with the license that allows us to do this. Similarly, for the WR1 program, an environmental assessment follow-up program will be put in place, or WR1 decommissioning will be put in place, and probably will be additive to this environmental assessment follow-up. So more additional post-closure monitoring will be added. And we're very confident in saying that the independent environmental monitoring program results for 2017, well, okay, there was an environmental program that was conducted by the CNSC and indicated that the results for that comparison in 2017, that the public and environment in the vicinity of the Whiteshell Laboratories site is protected, and that there's no expected health impacts to the public resulting from the Whiteshell site operations. Next slide. Okay, get this back. Okay, so the question is, you do all this monitoring, you do all this examination. What happens? What do you do if you get some unexpected results? Well, first off, results are compared to predict the values in the environmental impact statement and government benchmarks, such as provincial air quality criteria, environmental quality guidelines. And if we exceed these or we get unexpected results, what are we going to do? Well, the first thing, we're going to monitor again to make sure our results are correct. We're going to increase our frequency of monitoring so that we get a better picture of what's going on. We may add more additional locations, maybe closer to what we think is the source of the unexpected result. We could quite possibly expand what we're looking for, monitoring more environmental parameters. On a RAD point of view, you might look at more short-lived radionuclides that, or a different suite. For example, if we're in a decommissioning mode and we're decommissioning a building, if we find that excessive dust is being generated and it's windy, we stop work. And so we have rules and regulations on what type of wind can be, we can operate under. So it's under a sustained wind of less than 30 kilometers an hour is our limit. But in addition, if it's a particularly dusty work, we will use dust suppression, typically fresh water, to mitigate any possible or mitigate the amount of dust that could be released. Now, if we do find contamination in the future in the ground or in the groundwater. One standard process is to do different types of pump and treat systems. So you can pump the groundwater out and treat it, and either release it once it's been treated and it meets our environmental standards, or it's treated as waste. And it's important to understand that our monitoring plans are and will be reviewed on a regular basis moving forward. Changes are quite common in that we may find that a location has no contamination at all, in that we will, and either we can benefit from sampling other locations more, or if we find something that needs more investigation, we can focus more attention on it. But this ensures that our monitoring plans stay current and meaningful in support of showing, making sure that our site operates safely through the years. I think I can get the slide. Yes. So in summary, for the WR1 environmental monitoring, before the results of the radiological and non-radiological effluent monitoring program have demonstrated and are demonstrating that controls for the release of potentially hazardous substances currently in place at the Whiteshell Laboratories continue to provide substantial protection of the environment. The monitoring program confirms that the Whiteshell site is operating in a manner that protects the workers, the public, and the environment. We produce annual reports that are available on cnl.ca, as Alana mentioned when she first introduced us, and provide detail to the public demonstrating that our records show that we have been protective of the environment. During our environmental plans and processes, are put rigor into place to ensure that we will be protective of the environment during decommissioning. This includes monitoring dust, surface water, and groundwater. And in the future, while the radioactivity is trapped in the metals of the WR1 and decays, our monitoring will continue for as long as the regulatory CNSC deems is necessary. Currently, we're estimating or proposing approximately 100 years. And we as a company are committed to provide information on the environmental performance. And again, the reports with data from the Whiteshell site can be found on www.cnl.ca. And with that, I guess we'll be opening it up for questions.
All right, thank you very much, Chuck.
Thank you.
To remind everybody, if you do have a question, there is a Q&A button at the bottom of the screen if you're using the Zoom app. And through that, you can submit your questions and I'll get them here and we'll be able to answer them live for you. So while everyone's frantically typing away, we do have one question that I think we can start with here. So I'll take a crack at this one first and then I'll toss it over to you, Chuck, to see if there's anything to add. So the first question is the water tested downstream on the Winnipeg River? For example, the water that goes through Saugeen First Nation. Now, I believe that, I don't even remember the slide number, but Chuck showed a slide identifying several of the surface water sampling locations. So a lot of them are concentrated at the site and just a little bit downstream of our outfall station. But we did have several that are upstream and then several that were downstream. So as far as downstream as, I think you said, MacArthur generating station, which is about 28 kilometers. So, and then typically the results that are seen with those sampling locations is that as you move further and further from the discharge point, the concentrations or the detectable levels continue to decrease the further downstream you go. So the MacArthur Falls station at that point, we're showing that we're protective there. So it's inherent that the further downstream you go, as far as getting closer to Saugeen First Nation, the levels continue to drop off from there. That being said, if the community is interested in having more regular or sampling taken closer to the community, that's absolutely something that could be discussed through our ongoing engagements. as well as part of discussions around what our follow-up monitoring program should look like. So the key here with a lot of what Chuck is focused on is what we've currently done and the processes that we follow to identify proper sampling locations and report our results. But our follow-up monitoring program, while we know roughly what it's going to look like, it is open for suggestions on how to make it more inclusive of to identify information and parameters that are important to the people that are interested in this. So we want to make sure we do what's necessary to ensure protection of the environment, but we also want to do what's necessary to help improve understanding of that data or make it relevant to the people in the communities that are downstream of us and could be potentially affected by our site. So I hope that does answer the question. If you have any follow-up ones, feel free to drop them into the chat here. Chuck, I'll throw it over to you. Is there anything you'd like to add?
I just like to agree with what Jeff's been saying, is that we do monitor the Winnipeg River right down to the Great Falls area. Just to add to that, it's on a weekly basis. So we're all year long, we're sampling the water at multiple locations, including right at the site boundary. We take that every week, and we go down to Lac du Bonnet and then down to Great Falls, and we take samples. And absolutely, we're looking for engagement from the Indigenous peoples specifically to help us with our monitoring program and what direction it should be taking for the future. And so yes, we absolutely monitor the water all year, once a week, on the Winnipeg River.
All right. Well, I don't see any more questions at the moment. I don't know if that means everybody is frantically typing away. As I said, if anything comes to mind, feel free to drop it in. But with nothing open for me to start to answer, I will pass it quickly here to back to Alana Wilcox to give you guys some closing thoughts here. But again, if something comes up, we can always flip back. So we've got until 10 o'clock today.
Thanks, Jeff and Chuck. So that brings our session to a close. We will I'll talk slowly and see if any other questions come in, but our next webinar is planned for May 18th, and we will be polling our participants to see how well you know your facts on the WL decommissioning project. So please watch for future session invitations. They will come out via email to those that are on our email list, as well as Facebook posts and through cnl.ca. We hope that you found today's session informative, and we invite you to submit any further questions or feedback on today's session to wlcommunications@cnl.ca. And I have entered that email address into the chat on the right-hand side. And I'm just noticing actually a comment in the chat box. So Jeff, if you want to have a look at that as I continue to talk, and then I'll hand it back to you for after I'm done here. So we would love to hear your feedback in order to make these sessions as effective as possible. The email address, as I've indicated, is in the chat box, but you can also find it through our external website at cnl.ca. So Jeff, have you had a chance to look at that? Did you want to?
Yes. So, and I mean, thank you very much for the comment. And I agree. If things are done and nobody's told about it, it starts to erode trust, right?
Mm-hmm.
We want to be very open and transparent with what goes on at our site and the impacts that we may be having on the environment. So that's again why our environmental monitoring program and the results of it are posted on our website each year. As Chuck mentioned earlier on, why we welcome and encourage independent monitoring programs that can verify the work that we're doing. So it's not, it's less of a, this is what we did, trust us. It's more of a, we're doing well. We think we're doing well, and we invite people to confirm that we're doing well by doing any of their own independent monitoring. As far as notification goes nowadays, I do believe we have a better process in place for providing notification when there are any events on the site that we think require notifying any of the communities. That also being said, if that doesn't mean we strictly decide what people are notified about, individual communities will have their own preferences for what things they prefer to be notified about. And that's something that we can develop through our ongoing engagements and specific communications with our Indigenous Engagement Officer and our Indigenous Liaison Committees. So.
Absolutely. And I think certainly our approach to a lot of things has changed over the years, and absolutely we have made a move to become more transparent, and we have an obligation to disclose, and we also want to disclose and to be transparent and to ensure that members of the public and Indigenous communities are aware of what's going on, and we certainly invite those conversations and invite people to come to the site for a tour as we're able, COVID permitting, just to learn more about the site and things like that. So we absolutely are interested in doing that with you. So there is another question in the Q&A box, Jeff.
Absolutely. So I knew if we waited long enough, we'd get some. So, so this one I'm going to ask Chuck to try and answer if he can. Otherwise, I think we may have to get back to this person or to the attendees in general through a follow-up. But it says you show that the last releases for the past 5-6 years, which were well below the regulated limit, which is great. Has there ever been a year where the releases exceeded the limit from when it shut down in 1985? Now, I said I don't know if you'll have that information handy, Chuck, but
I don't have that handy, but although I was not here in 1985, for RAD, I know that we have not exceeded the limits for our derived release limits specifically, nor have we come even remotely close. These are the numbers presented were since 1985, which was the shutdown of the WR1. And it was placed into shutdown, and then was it 1996 it was defueled. And but no, from a RAD perspective, we have not come close to exceeding our derived release limits since 1985.
Excellent. Thank you, Chuck. And to follow up too, so again, I don't know how far back our monitoring reports go on our website, but we do have a whole many historical reports on there, so you can see the values over the years. If there's anything specific you'd like to see, again, please reach out to Whiteshell Communications at cnl.ca. If there's anything specific you're looking for, and we can do a little bit more of a detailed look at it and see if we can get you the information you're looking for.
Okay. With that, I will say thank you to all of our participants today. Very happy to see you all out, and many of you we know, so that's wonderful. Thank you for your interest in the WR1 reactor decommissioning project and for your time today. Take care.
Thank you, everybody.